Mercado-Molina talking about fireworm corallivory.
So this works.
The
Okay, perfect. Thank you very much, everybody, for being here. Sociedad, Ambiente, Marino is a non-profit organization based in Puerto Rico that for the last 20 years have been working on marine conservation and coral reef restoration. And we are not only interested in trying to increase the probability of population persistence of threatened corals, but we are also interested in trying to understand the processes that can drive changes in population size over time. And in this sense, it is known that predation is one of the factors that can put at risk the success of any restoration projects. And today I will be talking a little bit about the relationship between the fireworm and coral outplants of Acropora cervicornis. So everybody think Caranculata is a widespread polychaete that can be found both in temperate and marine ecosystems, and it has the ability to prey on different benthic species, including corals. In this sense, it is known that it can actually prey heavily on Acropora cervicornis. However, its feeding dynamics is poorly understood, thereby limiting our capacity to develop mitigation plans against predation. Taking that into account, we have 4 different questions for this presentation. The first one is that do predation rates vary in space and time? Is there a relationship between colony complexity and predation susceptibility? Are introduced colonies more likely to be predated than colonies that are already living on the reef? And does predation actually have a negative effect on the population dynamics of the coral plants or the restored population? So, in order to answer these questions, we follow the fate of a restored population at Punta Melones Reef in Culebra, Puerto Rico, where we established several transects of 60 meters square, each containing 150 outplants. And those transects were established along a grading of reef rugosity, A being the side with the lowest complexity, and C being the side with the highest rugosity levels. And within each transect, we are still monitoring colony in situ. We don't know still not using cameras, So we just tag them and follow the demographic performance, growth, survival, branching rates, and condition, even if they were predated or not predated. So, contrary to other studies that have been trying to figure out the relationship between the fireworm and the coral outplant, that have not found any temporal pattern, we did found that. We found that coral predation actually increased over time. I didn't tell you, we followed the fate from December 2020 to August 2022, so almost more than 2 years. And so we found that indeed, predation can increase considerably over time. Whoa, over time. Okay, so as well as prevalence, So this is at the end of the study, 84% of the colony were already partially consumed by the fireworm, and the fact that prevalence followed more or less the same pattern as the incident, increasing over time, suggests that coral outplants have not been able to regenerate the consumed tissue. The spatiotemporal, although the 3 transects follow the same pattern, increasing over time, we did find that location did actually play a role on that. Transect C, the one with the highest complexity, accounted for over 50% of the total colony that were consumed to the study. So that spatiotemporal pattern actually was supported by the log linear model that we performed. It was also found that the susceptibility to be predated increases with size and also increases with branching rates, with the branching rates. Okay, probably because being bigger and having more branches provide a higher surface area for the fireworm to feed without spending a lot of time just foraging around. Probably also the branching of the colony can provide some kind of protection to the fireworm. When comparing the probability of being attacked by fireworm, we actually found that those colonies that were introduced, that we collected from our nursery that put it into the reef, were more prone to be predated by the fireworm when compared with branches that were collected from the population that was already restored. Probably because colony that were already in our transit were already acclimate to the environmental conditions, or maybe because those colonies that we brought from the coral nursery were more stressed out. So we need to figure out, and we are looking forward for that. And with the data that we collected, we developed a very sick web population model based in two states, two site classes, small and large. And that was only, we are testing what's going on with the population just to calculate the population growth rate. And what we found against expectation is that population rates in a scenario in which we consider only predated colony actually have a higher population growth rate than when we consider in a scenario that we take into account those colonies that were predated and those colonies that were not predated, and when taking into account colonies that were apparently healthy. So that means, that suggests that other factors are driving the population dynamics of our restored populations, which is very interesting because we many times think that predation can have a negative effect on population. But what we think is that probably the abundance of fireworm is not that big now to cause a population decline on our. So does predation rate vary in space and time? Yes. Is there a relationship between colony complexity and predation susceptibility? Yes. Are introduced colony more susceptible to predation than colony? Yes. Does predation can drive a decline? Well, maybe not. We need more information about that. So being so, sorry that I take more time. Thank you for your attention and for
Thanks very much, Alex. We have a quick question while we're changing speakers.
Yes.